Hey everyone, Nick Raboy here from Couchbase. We're going to be looking at durability requirements for data when using the Couchbase SDKs. So if you're unfamiliar, Couchbase has an in-memory layer and then a persistent disk layer. And not all the time it's good enough to know that your data has just hit the memory. Sometimes you need that little more assurance to know that what you've saved into the database has actually made it to the disk or has actually been replicated or so on and so forth. But because by default, when you do any kind of save, it's going to happen against that memory. So we can actually alter this behavior by choosing our own durability requirements in the SDKs. So we're going to be exploring Node.js for this example. But the same rules apply for the other SDKs as well. So they should follow very similar, if not the same APIs. So we're going to go ahead and create a Node.js application. I'm going to walk through different scenarios on why you might want to use each of the durability requirements that I propose. So let's go ahead and go into a terminal. We're going to create a new project. I'm going to create it on my desktop. I'm going to say make directory durability project, and I'm going to navigate into it. Then I'm going to say npm init -y, and what that's going to do is it's going to create a new package.json file for me. And then inside that package.json file, I can say, well, not inside the package.json, but inside this project, I can say npm install, say Couchbase UUID, and then let's go ahead and say save. So with the project created, let's go ahead and create a file that's going to contain all of our source code. I'm going to call this app.js, and you should have a project that looks something like this. Now I'm going to go ahead and open it up in an editor. I'm going to be using Atom. It really doesn't matter what you choose to use for editing your project, but just note that what I'm using. So go ahead and open up your app.js file, and we're going to start by including the dependencies that we downloaded. So we're going to say const Couchbase equals require. And let me zoom in a bit. Require Couchbase. I'm going to say const. I believe I included the UUID package somewhere in here. Yeah, UUID. And this is going to be used for our unique document keys. Now what I'm going to do is I'm going to say variable cluster equals new couchbase.cluster. And I'm going to provide it a URL that has my Couchbase instance. So in this case, it's not on my local machine. So I'm just going to obtain the IP address here and paste it in. Make sure that you remove the slashes on this HTTP bit. It's gotten me several times before where I didn't know what was going on, but I found out that later that I had included HTTP by default or by mistake. Just go ahead and remove it if it included it in your paste. The next step is we want to say we want to say cluster.authenticate, and we want to provide it a username and password. Now I believe my username and password is example and then 1 2 3 4 5 6. But if that doesn't work, we're going to change it in just a second. And this is for your role-based access control. Then finally, we're going to open up a bucket. We're going to say var bucket equals cluster.openBucket, and I believe my bucket is also called example. So we do have a connection to Couchbase at this given time. We're going to say var, and we're going to say data equals, since we're not going to create an API or anything behind this project, we're going to include data, and we're going to say first name, Nick, we're going to say last name, Raboy, and that's enough for our data for this example. You know what, maybe we'll include a timestamp later on. All right, so let's consider the options that we have when it comes to inserting data. Typically, if you look at the documentation around Couchbase, you probably see something that looks like this. Bucket.insert, you provided a key, so we would say UUID.v4 as our key. And as far as our data goes, let's provide data, and then error, and then result. And the result is just ever going to be a cast value. Now, if there's an error, we can throw it. Otherwise, let's go ahead and just print out that cast value for this example. All right, so by default, if we did this bucket.insert, what it would do is it would insert it into the cache. And then over time, it would then persist it to disk, and then it would replicate it to a different node in the cluster. And we can test that by saying node app.js. It returned as suggested, so we can go ahead and stop it. And if we go to our database instance, I go to buckets. I already had data in this bucket, but that's all right. We can see that that document was since created. Now, that scenario works great if you're trying. So let's say you have an online game, an MMORPG, so a massive online role-playing game, where you need to track the player's state every X amount of seconds or minutes, or it doesn't even matter. In that scenario, if it hits the cache, and maybe it hits the disk, maybe it doesn't, that's all right, because you're frequently tracking data enough to where if the node fails before it ever hit the disk, you'd be all right if you recovered and got the data where it left off. There's plenty of other scenarios where you'd be fine, where you wouldn't ever need to rely that it did in fact hit the disk or so on and so forth. Knowing that it hit the cache is good enough, because when you hit the cache, that's going to be the fastest opportunity to get a response that you can get. Now let's say that it's not enough. Let's say that we're creating some kind of ordering system, and we need to know that our orders hit the disk. So we go back into our application, and we change things a bit. We need to change our durability requirement. We need to say, you know what? Before we get a response, we don't want to know that we saved it to cache. That's not good enough for us. We need to know that it persisted to at least one disk before we get a response. So it needs to have hit the hard drive, not just the RAM. So what we can do is we can change this bucket.insert line. We can actually say persist to, and provide it how many nodes we want it to persist to before it actually responds that it's all right, that it's saved. So we're going to say one node, because I'm just running a one node cluster right now. So by saying this, let's go ahead and we'll run it again. I'll just change the name here. We'll go ahead, open up our terminal. We'll say node.app.js. It's saved, and it saved it pretty quickly, just like the other example. So I'll go back to Couchbase server dashboard here. And it said persist to 1 because I actually made a mistake. So I actually made the wrong order of commands here. So it was supposed to happen after the data, not before. So let's go ahead and copy it. So we save that, we change this back to Maria, and we're going to try to run it again. We ran it. It didn't take any noticeably longer than the previous. So I'll stop it. I'll go to the Couchbase dashboard, and it did in fact save as it should. So in theory, it is going to be slower to persist to the disk before versus the other solution where it was just before it was just going to the memory. But you know what? Some application needs require that your durability requirements say that it goes to disk before we can say that it's a successful save. Now, there's other scenarios. So let's say you have some kind of maybe banking application. It's critical that you never ever lose someone's data. So let's say that you're worried that you've saved it to disk because you've done the persist to, and you're worried that that particular server node fails. You get kind of massive hard drive corruption, things like that, and you're not convinced it's ever going to be replicated or backed up first. So what you can do is you can actually change your logic a bit. Instead of persist to, which you can leave, what you can also say is you can actually say replicate to, and you can actually define how many nodes it should be replicating to before it's a successful response. So in this case, if I say 1, it would say, you know what, it has to persist to one node, and it also has to replicate to one node. In this case, replicating to the cache is fine. I could increase that number on either of these values Again, the higher the number, the slower the response. But that's not for me to decide. That's for you to decide on what your application calls for. So if I save it, it might not work because I only have one node in my cluster. But let's go ahead and run it again. We'll just change it up a bit. We'll change it. We'll say save. We'll run it. And it failed because I don't have enough nodes or replicas to meet these durability constraints. So that's a good thing. It told me that, you know what, my application won't ever meet this need. So if I added another node and then I tried the replicate to command, it would work fine. So you just saw 3 different ways when it comes to saving your data in Couchbase. And this is all for the writes. When it comes to reads, there's if you're doing queries, you can define your own scan consistency, so you can define whether or not the index has updated or not. But this is strictly in terms of write. You want to know, well, did my data hit the cache? Did it hit the disk? Or did it even replicate? And depending on your application needs is what you need to define in this command. And it's very easy. It doesn't cause any stress beyond just a slower response time.